All right, so we are in geometry. Today's date is Tuesday, March 3rd, 3/3, 2020. We are on sectors. And if I was being a little bit more specific, I could say sector area. Yes, Julian, what is our objective today?
Some problems relating central angle area sector.
Thank you.
How do we all...
All right, so I think of a sector as a pie slice, like how much pie am I going to be eating? So let's think of this, I'll put it in like quotes here. A sector is a pie slice.
So it's different from a bisector, an angle bisector?
Is there a choir saying out there? Oh yes, Andres.
Is it different from an angle bisector, just a bisector?
Yeah, so an angle bisector means to cut in half. Bisect, sect just means to cut. So I'm cutting a piece of pie. And it doesn't have to be from the central angle, but I will always make it from the central angle to make it easier for you guys. And so will Con. Until maybe at the very, very end, I might mix things up. So it's a pie slice. It's really area. So it's part of the area. Part of the area. So let's look at our diagram over here on the right hand side. If I were to cut off a pie slice, let's just go from the central angle, so from here to there, just kind of a random pie slice. That right there, if I shade in this area, this is the area, and I'll call this area the sector. We'll say that is the sector. I can probably write a little bit neater.
Area is the sector.
Yeah, and then you usually want to have it from the central angle. Especially for today's lesson, 100% of the problems are going to be from that central angle. So different sorts of pie slices. All right, no questions up to this point, pretty straightforward. All right, what is the formula for the area of a circle with a quiet hand? Sergio.
Is it like 2 pi or 2 pi r?
2 pi r is circumference, so we'll come over here. Circumference is equal to 2 pi r. Good guess. It's very similar to that. Andres?
Pi r squared.
It is indeed pi r squared. If we could all write those down.
Thank you. Hey, this is mine. That one's mine, I'm sorry.
Wait, Julian didn't participate though.
You read the objective.
Yeah. But...
All right. So, how do we find the sector? Well, I gave you this table. How do we find the sector? Well, if it's in degrees or radians, it will be affected. Again, it's the same idea with part divided by the whole is going to equal the part divided by the whole. So, I'm always going to do angle on the left, and I'm going to do now sector area on the right. So, with the quiet raised hand, what is going to be the left fraction over here for degrees? It's the same thing we've been doing over and over and over again. Yes, Gunnar? What?
Oh, wait, never mind.
Gunnar, I can't see your ears from back here either. All right. So, what do we have on the numerator for the top left? 360 is going to go on the bottom right. Yeah, 360 degrees. And then, so that's the entire angle, a full rotation. And then part of that, what variable do we normally use for a partial angle? Do you remember what this one is called?
Oh, theta.
Theta, yes. All right, I'll take the card from you, Gunnar.
Can I go again? Because that was like bad.
Yeah, I'll try calling you again. All right, and then this one over here, I'm just going to write the thing that we're trying to find. I'm going to call it sector area. Sector area. And what do you think should go on the bottom now? This is going to be a little bit different than last time, because if it's sector area for the part, what is the whole? What is the whole? What is the whole? If the part is sector area, what is the whole? Yeah, Cohen.
Pi r squared.
Pi r squared, there it is. Thank you. Pi r squared. And I'll put in parentheses, if you don't know what that is, that's the whole area. The whole area of a circle is pi r squared, and then we'll find the sector area. Nice. All right. Let's move on to almost the same exact formula, but now in radians. How do I do that? With a quiet raised hand. Who's got this? Fernando.
So it's like what, theta?
Theta
Over 2 pi.
over 2 pi.
And then would be sector area.
It's still sector area, yes.
And then pi r squared.
Over pi r squared. Beautiful. Thank you. See, you don't even need to memorize them because you've already memorized them. They're that easy. If I'm trying to find sector area, then that's the part that I'm trying to find. And then you should know that the whole area is pi r squared. You've probably seen this repeatedly in 7th and 8th grade. I think we use it a little bit in Algebra 1. I don't know how much we use it, but you're going to be using it definitely a ton now in Geometry 2.
We've never seen it in 7th or 8th grade.
Is there a quiet raised hand out there who said that? Oh. Yeah, Gunnar.
Thank you, Gunnar.
Oh, okay. So you've never seen pi r squared before today?
No.
Never. Okay. So pi r
Maybe
squared.
Algebra 1, but
I thought I proved to you guys where pi r squared comes from. I showed you a video on it.
never did. No, you didn't.
Never?
You just said, oh, this is pi.
Now you need to show
Oh,
us.
I guess I need to show you.
So,
Good at it. It looks like you have a pi squared.
What?
Yeah, good at it. You heard it.
I never showed you this video. Okay. I'm gonna stop recording. All right. So let's try out our new fancy formulas. Example number 1. We have a circle with an area of 25 pi, and it has a central angle of 2 pi over 5. I haven't said so, but that's in radians, if you can't tell. It does have a pi in it. I need to find how much pi am I eating? How big is that area right there, that sector? How am I going to do that? Quiet raised hand, help me set up a problem. Someone new, someone that has a card. Yes, Jenny.
It's not Jennifer.
Dang it. Whose card is it? Is it Cohen's? I did not grab Cohen's.
No.
Jessica, go for it. Read one of those two formulas that we have in the box up here. Are we in degrees or radians? Yep, we are in radians because we have 2 pi over 5. So read off our formula and fill in as much as you can.
I don't know.
Okay, so this theta is that central angle. What is our central angle here? Yeah, 2 pi over 5 is this theta, so I'm replacing this theta right now with 2 pi over 5. 2 pi over 5. Okay, that's all divided by what, Jessica? 2 pi, perfect. So you have the left-hand side of the equation set up. Now let's do the right-hand side.
Would it be 25?
25 pi for the area, and that goes where, on the top or the bottom?
Top.
Not quite. So remember that the bottom is the whole area.
Oh, bottom.
Yeah, so it's going to be 25 pi in the bottom. And what should we put on the top?
I don't know.
So we're trying to find the area of the sector. We're trying to find the sector area. We're trying to find the sector area, so you can call that whatever variable you would like. Sure, X. This is so much fun. All right.
Whoa. What happened, Mr. Chanel?
People are not listening. They're deciding to be disruptive.
What hours? Wait.
All right, so Jessica set up our formula. Thank you, Jessica. Sorry for people interrupting you. From here, what do we do?
You know,
A question, Sergio?
can you cancel 2 pi?
You can, but you have to be careful about it. So it does eventually cancel out, but again, I'll do it a little bit longer. So the answer is yes, but be careful. How do I solve embedded or nested fractions? We've seen it before. I saw it yesterday. You're going to be seeing it again today. Whenever I have nested fraction, a fraction within a fraction, how do we do that? Look back at your notes then. We just did it yesterday. 6-3. Look at your notes. We had problems where I had a fraction inside of a fraction. Use your notes. Find a problem that had a fraction inside of a fraction. I'll call on any raised hand with or without a card. Is it a raised hand, Andres? Yeah, is that your card?
It might not be, but it's like, can I still answer the question?
Go for it, yeah.
So, in order to not get that fraction over inside a fraction, you have to divide that fraction, but you have to put like the divide symbol.
Oh, this right here? Okay. Divide by 2 pi.
2
Yeah.
pi.
Exactly. That's the solution. Thank you, Andres. And I'll take whoever's card that is.
No.
Next time, turn in your card.
How'd they get over there?
I haven't.
Hopefully no one is throwing stuff. All right, so from here, I do what? Next step. To get rid of a nested fraction, you use this division symbol instead of a fraction symbol. I'm going to give it to someone that has a card still. Jose.
I actually want to answer this.
Keep it, change it, flip it. So it turns into... Right, there it is.
Yeah.
All right, by the way, this right-hand side has not changed. This right-hand side is still x over 25 pi. It's still equal to x over 25 pi. We have not touched that yet. Right-hand side has not changed. We've only been working on the left-hand side. And I'm going to make this slightly smaller because I need to get some more room. This is x over 25 pi. All right, so I'm going to come back up here and keep working. All right, so what do I really have on the left-hand side? All of this 2 pi over 5 times 1 over 2 pi, that simplifies into what on the left-hand side of the equal sign? Looks like it's going to be another cold call.
Need cards?
Let's go with Monse.
Yeah.
Yeah, you can just multiply across. So what do I have? There it is, yeah, 10 pi. And then the right-hand side still has not changed. It's still x over 25 pi. Thank you, Monse. From here, I can reduce that left-hand side. Who can see how I can reduce that? We'll give it to Eder. Sergio's giving a hint if he needs it. What do you see, Eder, on the top and bottom that can be canceled out?
Pi.
Yep, the pi. And what about 2 and 10? Can I divide the top and bottom by some number?
2.
Okay, so what's left on the top then? 1. And then on the bottom I'll have a 5. Yeah, nice. So 1/5 is now equal to x over 25 pi. Thank you. Oh yes, exactly.
Oh, that's just, no, this is not what it looks like, you know.
And then...
I'm your assistant though.
All right, finally we can actually deal with that right-hand side. Whenever I have a fraction, just one fraction, not a nested fraction, a fraction equal to a fraction, now I do what? With a quiet raised hand.
Is that your hand?
That's my card, yeah.
Yes, Jenny. Yes, you do. And go ahead and do that without any help from Andres now. How do you cross multiply? Do this way first, if you want. 25 pi, keep going. Yeah, perfect. Thank you, Jenny. And before he steals your card.
Here you go.
And finally, to solve for x, the thing that we were trying to... I thought she already has her card in.
Wait.
Wait, didn't you participate already, Jessica? Yeah. I just need to come and get your card. If you can pass that around to me, not that way. Yes, ha ha ha. All right, Josie, I think it's you. What do I do? Buy. Ooh, careful. Not 25. I'm trying to isolate for that x, so divide by whatever's in front of the x. Yeah, nice. And then what is this left-hand fraction going to be? 5 pi, yeah, is equal to x. Done. Box it.
That's it.
That's it.
There you go.
Yeah, I'll be Yeah, so we figured out how much pi am I eating. This amount of area amounts to 5 pi.
That's what I got.
Yeah.
So, your question?
If you do like an exact answer, you do 5 times 2.4 times 5.
5 times 3.14 times pi.
Not like 3,
Huh?
not like 5 times 3.14.
Oh, you can get an estimation, yeah, so it's a little over 15, right? It's probably close to 16. Let's keep it exact. Let's just enter 5 pi, and then we get it perfect. Let's try another one, and then we have another one. Yeah, we have 3 examples. So example number 2, it's slightly different. I'll help you get it set up, and then I'll leave you guys with it.
That's my.
So,
Oh my god.
No, you know I didn't mean it.
No, I'm a good noodle. Don't take a star with me.
all right. Don't worry, it's just a test grade. All right, so from here,
Wait.
again, behavior is as much as it is to get a test score, right?
Yeah.
So from here, someone with a quirist hand, help me figure out this formula. I think everyone is in now, right? Is there someone that I missed? With any quirist hand, I'll call on you. How do I set up this formula? It's one of these 2 formulas up here, degrees or radians. One of those 2 formulas. Jose, go for it.
The degrees formula?
It's not going to be degrees, unfortunately, because that angle right here is not in degrees. It's going to be in radians. Yeah, can you tell us what's going to go where?
Pi over 3
Pi over 3,
over
all over,
2 pi
all over 2 pi is equal to.
to s over pi r squared.
So you're close. We actually know what S is, I think.
Oh,
It says the
Oh,
sector
4.
area is 4. Yeah, so we'll come back here and say, yeah, that's 4. And what are we trying to find here? What's the question, Jose? Area. So let's just say that's area. That's the thing that we're trying to find. We don't want to find R, we want to find area. Cool, so Jose has set up a formula for everyone. I want to see if everyone can now solve that formula. And then when we hit example 3, in fact, I'll just give you the instructions right now. Try to do example 3 all on your own, where you have to set up your own formula. You can work with people next to you if you want, but now no official help from Mr. Sindel unless you specifically ask for it. Yeah, Fernando.
What's that A under the 4?
A stands for area. I could have called that X. I just chose A because it made sense to say that is our area down there.
So
So
whenever.
pi
Oh,
r
sorry.
squared.
We're not doing pi r squared because it's not asking. If we were doing like what is the radius of the circle, then yeah, we'd use pi r squared because the unknown thing is the thing that we're always trying to search for. We're trying to search for area in this case, and area is that whole entire denominator. So we have to be careful about how we set up our fractions. Yeah,
You gotta read our question properly. Yeah. Correctly.
precisely. So good luck, guys. You can work with people around you. We're solving all of example 2 now that we have set up the formula, and then we're going to solve example 3 right after we do that. As soon as you've checked example 2 and example 3 with at least one other person, that person might be me, go ahead and begin the work on Khan Academy. We just have one homework assignment tonight, and be ready for the quiz tomorrow.